So now we're looking at group 17, the elements known as halogens. So these are also called group 7, that's the older name to use it, and now it's called 17. Earlier times we used to call this group 1, group 2 in the periodic table, group 3, 4, 5, 6, 7, 8. We have actually moved the numbering to even the transition element series. So that particular row also gets numbered. So when you number that, what, 9, 10, 11, 12, then the 3 becomes 13 and the 4 becomes 14, and therefore 7 becomes 17, and that group is the one we're going to be studying. They're called halogens because the term is derived from a Latin term, and that means salt makers. Okay, and the reason why we study them is because they are reactive nonmetals, and what they do is they form salts with metals. That's what I do. That's what they do. Now the reason why we'll be studying them is because, like I said, they're reactive, they make salts, they have a lot of properties. But generally speaking, this, if you start from the physical properties, these guys are, all of these are they exist as diatomic molecules. So they are diatomic molecules, and the basic structure, like is X2, like Cl2, Br2, I2. We tend now to study fluorine, is highly small and not really properties are common to all of these three, but we'll talk about that later. They're diatomic molecules, which also means they have a simple molecular structure, and because they have a simple molecular structure, the intermolecular forces they have are, you can say, they're held by weak instantaneous dipoles, induced dipole attraction. Now this attraction is also called London forces. We used to also call them van der Waals forces. We keep changing their name every so often, so everybody calls it differently, but they all mean the same thing. And because they are held by weak van der Waals forces, they are volatile. Okay, and they are reactive, which we'll study later as oxidizing agents. And when they reactive to form the other form of them, which is called the halides, like the chloride, bromide, iodide, and all that. And obviously when we talk about the reactivity, we'll discuss them there, but generally speaking, the reason why they're reactive is because all they got to do is gain one electron in the outermost shell, and they are sorted. If I focus on the configuration of these four, I'll put it right here. In fact, I'll make some space first. I can move everything to the left, move everything to the left, and then I'll place that here. What I have placed here is the electronic configuration of fluorine, chlorine, bromine, iodine, the first four. All of these configurations, NP5, all of them, for them to react, just have to gain one electron. So like I was saying, these guys have to gain one electron. Any of these halogens, X2, each element of the X can gain one electron to become a halide. That's generally how they react. Then I'll talk about their colors, the elements and their colors. Here is, we have the gaseous version of the four halides in these jars. The leftmost is fluorine, the middle one is chlorine, and this one is bromine, and the last one is iodine. These are all their vapor forms, right? And you have to know what they're generally speaking, the state at room temperature. So that's different. State at RTP. Generally, you'll have to know that fluorine and chlorine are gases at room temperature. Bromine is a liquid at room temperature, and iodine is a solid at room temperature. And then you also have to know the colors of these guys.
Quick pause. If you're finding value in this explanation, there's so much more to discover at Alt Academy, where we break down every A-level concept with the same clarity. Now back to the video lesson.
So generally speaking, the color for fluorine gas is yellow. For chlorine gas is green. And bromine is considered red-brown liquid. And if it's an aqueous form, it can be a little less, which is like orange. Now iodine has multiple colors. Iodine in the solid state, which is what we find at RTP, is a gray solid. Iodine as a vapor is purple in color. There are two different colors, purple or violet, right? Most people call it violet. I don't know why, but that's what they call it violet. Yeah, so let's call it violet. And in the aqueous form, funnily enough, iodine, if you had it in the aqueous form and that exists, it was red-brown. While bromine, so Br2 aqueous, is considered orange because it's a lighter version of red-brown. But iodine actually changes color, you know. So it's gray in the solid state, it's violet in the gaseous state, and it is red-brown in the aqueous state, aqueous water state. Okay, that's what you got to remember. And they will ask this, so you'll have to know their colors. It is imperative that you know their colors. All right. And obviously things like, because it's a periodic table, things like when you go down this list, so now I'll talk about that table again. Okay, the properties of the atoms. So as you go down this list of halides, okay, as you go down this list, a few things happen. Atomic radius increases. Okay, and what else do we know? Down the group, atomic radius increases, and the anion radius also increases down the group. Then the other part is the anion radius is larger than the atom's radius because they've gained an extra electron. And first ionization energy, like all elements down the group, first ionization energy down the group, what happens to it? Decreases down the group. Even though they don't naturally make 1 plus ions, but if they were to, if we know that ionization energy decreases down the group, it's the same reason as it decreases for any group down the group, or even group 2. It's the same. Down the group has the increase in nuclear charge is outweighed by the increase in shielding and increase in size. And one more thing you must know as you go down the group, the electronegativity also decreases. Negativity decreases down this list. The guy on the top is the most electronegative. The guy at the bottom is the least electronegative. And the next property that we'll talk about is down the group also boiling points increase. Okay, down the group. And that's the graph I want to show you guys. So down the group, boiling points increase. Now why do they increase down the group? Because as you go down the group, what's happening is number of electrons in the diatomic molecule increases. Therefore, the strength of instantaneous dipole, induced dipoles, attractions increases. Therefore, boiling points and melting points will increase. And they expect you to know that, you know, and write the reasons for. And the reasons were that down the group, the electrons, there are more electrons, so stronger. And that's why they go from gas, liquid to solid. Okay. And the last thing I'll talk about and a little bit is electronegativity. So as you go down from fluorine to chlorine to bromine to iodine, the electronegativity values, remember the most electronegative element in the world is fluorine, given a value of 4.0. and then it's chlorine about 3.0, bromine is 2.8, and iodine is 2.5, and that is decreasing. And why does electronegativity decrease down the group? Because the ability for these atoms to pull electron pairs decreases because they get larger, and the shielding effect and the size decrease each element's ability to pull electrons. Therefore, electronegativity decreases. Now, you won't need to know the values. I'm just showing the trend, remember. But the idea is that down the group, the shielding effect, and by the way, this is the same reasons we have for ionization energies. The shielding effect increase and the atomic size increase outweigh the increase in nuclear charge. That's why both ionization energies decrease, easier to kick out, harder to gain down the group. Okay, which by the way also tells me something. Becomes harder to gain electrons, which in chemical properties means down the group the oxidizing power or ability for these fellows decreases, because oxidizing ability is I2, like this. What I'm saying is the compare chlorine's ability to gain 2 electrons to become chloride is much greater than iodine's ability to gain electrons. Both of these here are acting as oxidizing agents, but chlorine is a stronger oxidizing agent than iodine. Down the group, the strength of oxidizing agent decreases. All right. Hey there. If you found this A-level chemistry lesson helpful, why don't you head over to our website, altacademy.org, where you can sign up for the full A-level chemistry course. In addition to chemistry, you can sign up for physics, biology, math, or 4 other A-level subjects. Thousands of students have already taken the leap. What are you waiting for?